Young people, welcome back. BNB in the house, y'all. Real excited, real excited. We have a lesson that you are going to love if you like fractions, and we all do. All right, maybe you don't, but we're going to get at it, you guys. So we're looking at chapter 11, lesson 6. Let's see those objectives. Add and subtract rational expressions with like denominators. We like it when it's like denominators. Add and subtract rational expressions with unlike denominators. We don't like it when they're unlike denominators. So, we're back. Students will be able to add and subtract rational expressions with same denominators and with unlike denominators. Concept, rational expressions, big old fractions, I like to call them, and the skill adding and subtracting. So literally before we get started, I am going to talk about the importance of knowing LCD, least common denominator, or what we can call it LCM, least common multiple. So if you know your multiples, boom, 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 that's good. 2, 4, 6, 8, 3, 6, 9, 12, 5, 10, 15, 20, multiples, right? We're gonna have to know multiples for something a little bit more complicated than that. And let's take a look at it. Let's get it, y'all. Here we go, here we go. So, nice handout, guys. And again, as you already know, we won't be doing the entire handout because this skill will actually take a little bit of time. So we're definitely gonna get to the bottom half, down there at 20. But of course, let's start with the beginning so that we can understand the beginning. And as I said earlier, guys, LCD. So rational expression, what I like to call is ratio. So a ratio comparing two things, or a fraction, right? But number one, since they have the same denominator, I'm going to write those numerators both in the top. 2y plus y. There it is. And you get 3y. So 3y divided by 5. Nothing challenging there because I have the same denominator. And number two, they have the same denominator there as well, 9. So again, 4r plus 5r, all divided by 9. And recognizing that I can simplify a fraction, I'm just going to get r, because the 9's cancel each other, right? For 3, you get t plus 3 divided by 7 minus. Ooh, good catch there. You guys see that? Be real careful today, distributing your negative. So a negative t. So a negative t and a positive t would cancel each other, so you're just left with 3 in the numerator and a 7 in the denominator. So all through the top here, guys, you're going to recognize we have the same denominator. Adding and subtracting rational numbers with the same denominator. Now here's my negative that I need to distribute. Already you can kind of see the minus c plus 6 divided by 4. So same denominator, so distribute the negative to the c and the negative to the 6. And let's get it written out correctly. C plus 8 minus c, or plus a negative c, plus a negative 6. Ooh, negative 1c. I like it. Invisible 1, we got it, right? So here, guys, of course, and keeping it in the parentheses, no big deal, but just collecting your like terms, you're going to have your c and c, which will cancel. I'm sorry, c and negative c, which will cancel, and then 8 negative 6, which is 2. So 2/4, which will give you 1/2. Good job, guys. So next one, again, just straight into it. X and x give me 2x. 5 and 2 give me 7, and they have the same denominator of 3. So everything was left on the top, and I just collected like terms. Over here, recognizing again that I'm going to run out of room. Well, you have a positive 2 and a negative 8, so when you add those two constants, you're going to end up with negative 6. But wait, you can simplify. So remember I said about simplifying your fraction? Well, this one we can factor out a 2 from that 2g minus 6, leaving you with 2 parentheses g minus 3. Factor the 4 in the denominator, 2 times 2, and now you can cancel those 2's. 2 in the numerator, 2 in the denominator, and then you get g minus 3 divided by 2. That is much better, much better. And honestly, too, it will be the answer in the multiple choice, so if you don't see that, you might think you're doing something wrong, but you just didn't simplify it completely. Here we go, guys. Again, the minus between those two terms, those two expressions, allows me to know that the x minus 1 in the numerator is because it is minus between those two fractions. That's right, I call it a fraction. Same thing here. It's minus r divided by r plus 3. So the r plus 3 is the same denominator, so we're just going to take 3r and then minus r, or 1r, right? Because what's in the numerators can be combined, and then the denominators are the same. We're good just to write them all on the top. So the first half, guys, all lovey-dovey, because they were all the same denominator. But it ain't no love in the heart of the city. But if you can get this, and you got that, then you deserve that, right? So LCM, guys, least common multiple. Replacing the M with the D, because denominator is what we're talking about, right? The denominator is what we're trying to get common. We need a common denominator, so we're gonna find the common multiple. So jumping into the coefficients, I got 4 and 12. Well, 4 times 3 is 12, guys. Yes, so 4, 8, 12, 4 has a multiple, yes, 12. So you're good. Now, x squared, y squared. Well, just think about this, guys. The first term has 2 x's. Well, okay, then I need 2 x's for them to be common. The second term had 2 y's. The first one only had 1. So to be a common multiple has to be y times y, because the second term is y times y. You got it? We could write it out a little bit longer, but I think if you're in class and your teacher talked about this, hopefully you got it there and got a little bit more here. But now number 10, definitely a little bit different. And we're gonna take pause. This is for my editor. Pausing it up because just how quick I got number 10. Hopefully you remember when you had different denominators, when it was 1/3 plus 2/5. You took the 3 and you took the 5 and you just multiplied 3 times 5 and got 15. And that was your least common multiple, or least common denominator, right? So technically, if I have one denominator and another denominator, I just multiply those two by each other and I have a common multiple. For example, again, 1/2 plus 1/3. Well, 2, that's one denominator. 3, that's the other denominator. What's 2 times 3? 6. I don't look like 6, but you get the point. So now where I have a binomial, I'm gonna do the same thing. I'm gonna have one denominator, which is a binomial. I have another denominator, which is a binomial. I'm just gonna multiply them by each other to get a common multiple. That's it. So we're gonna see that a lot here. And I'm gonna keep talking about it too. So as we undo this pause, let's get it going, guys. And we're already done with 10 because I'm showing the example here again. 2/3 plus 1/8, again, different denominators. But if I multiply 3 times the 8, there you go, 8, I'll get a common multiple. So showing it with just basic fractions so that we understand it when we have to do it with our rational expressions. So 3 times 8 is 24, and 8 times 3 is 24, so you have a common denominator, common multiple. So the same thing, yeah, the same thing, common denominator. So over here with 11 now, and what's pretty cool is you're gonna see this throughout, because it's just gonna keep happening over and over. All right, I'm finishing it up. All right, yeah. I gotta finish the simple fraction addition up there. There we go. 8 times 2 give you 16. Because what you do to the bottom, you're gonna do to the top. You're gonna see that later on. So when I multiply the bottom by a binomial, you're gonna see me multiply the top by the same binomial. Whereas here I multiply the bottom first fraction, 2/3 times 8, and then I multiply the top times 8. So 2 times 8 was 16, and 3 times 8 was 24. And then the second fraction, 1/8, 1 times 3 gave me 3, and of course 8 times 3 gave me 24. So I'm doing the same thing here, guys, where the common multiple is the first binomial, 2r minus 1, and that's why I do this, the first binomial times the second binomial. And I keep them in those parentheses, literally. I'm okay with that. For 12 though, there's a GCF, and I already pulled it out. 4t plus 16, pull out your greatest common factor of 4. 4 comes out, oh, it's gonna go fast. And you get, oh, it's still there, good job. So, the 4 comes out of the second binomial, 4t plus 16. So I get 4 parentheses t plus 4. So now I have a few multiples I'm thinking about, a few factors I'm thinking about. Thinking about the t plus 4, the first binomial. I'm thinking about the 4 that I pulled out, and then I'm thinking about that other t plus 4. So see there's 3 there, where normally we've only had 2. Well, that's what I'm recognizing. No doubles needed. Just have the 4 and the t plus 4, and that's your common multiple. Yeah. So this section here, guys, was literally for us to see it without it being a fraction, because we're going to have to determine what is the LCD or LCM, least common multiple. So here, as I'm looking at 13, getting a nice squared in there, 5 divided by 4r, r minus 2 divided by r squared. So I see that one denominator is 4r. There's a 4 and an r. 2 times 2 times r. Those are my factors if I wanted to factor it all the way out. The second denominator is r squared, which is just r times r. So I'm thinking, okay, well, the first one just needs another r, and the second one just needs a 4. Literally. So we're using what we call the big one. 4 divided by 4 is 1, so we're not changing it. Same thing we do with the regular fraction. So, and on this side, like I said, guys, I just need another r, and then they'll match. So in my mind, I'm understanding what I'm doing with the blue, big one, and the green, big one. So 5r is now divided by 4r squared, and 8 is divided by 4r squared. So they have the same denominator, just like we did before, guys. Keep them in the top. So 5r minus 8, all divided by 4r squared. Bam. And again, let's see it again, all right? So that's 13, 14, 16, 18, they're on a different slide, right? But 15, we got our first binomial in the denominator, x plus 2. And then of course, it's gotta be minus, wanna make it complicated, right? No, I'm just kidding, not complicated, just challenging. And x minus 1. So you see those parentheses, I started there because my mind is already thinking, all right, you know what you gotta do. X minus 1 over x minus 1, which again is just 1. I'm not changing my first expression, it's multiplied by 1. I'm just using what I need. I'm using the binomial in the denominator of the other one. And then of course, I'm gonna use the binomial x plus 2 for the other one. So again, 1 in blue, 1 in green, but exactly what I need. Just like I said before, we took the 3 and the 8 and we multiplied by each other. But it's not 3 and 8. X minus 1 and x minus 2. So we're gonna multiply those by each other. And technically, we're really not even multiplying them out. We're just gonna leave them as binomials. We can do that. So x times x minus 1 minus 4 times x plus 2. So let's go ahead and simplify, guys, since we can do that numerator, we can do what's up there. The denominator is our common denominator now. So thinking about, you gonna finish it up there? I guess so. X times x, I'm just gonna write it out nice and pretty for you. Because we know you gotta take notes. X times x is x squared, x times negative 1 is negative 1x. And then of course minus, and see how this time I'm writing it still as 2 rational expressions up there, whereas down there, I just wrote it all out in the numerator like we did at the beginning of the handout. It's what works and what your brain is telling you, right? 4 times x gave me 4x and 4 times 2 gave me 8, but please do not forget there is a minus, right? Oh, look at them beautiful colors. Beautiful highlights. Somebody cares about y'all, they're using highlights. All right, distribute that negative because of course it's the opposite, so now it's a negative 4x, good, and a negative 8. Collect some like terms. I can collect the middle terms of negative 1x and negative 8x, which will give me a negative 5x, x squared minus 5x minus 8. And I believe I will be done there unless I can factor the numerator. That is a simple trinomial. And I'm thinking what multiplies to give me a negative 8 but adds up to negative 5. Well, again, guys, if you saw some of the earlier videos, you should know what multiplies give me 8. 1 times 8 and 2 times 4. None of those will give me a difference of 5. And I say difference because I'm a negative, and we're talking about factoring now, where we are really talking about adding big old fractions with letters in them. That's right, fractions with letters in them. B divided by b minus 1, and 2 divided by b minus 4. So again, I've got two different denominators, and they're both binomials. So my brain's just saying, okay, multiply one binomial times the other binomial, and you'll have a common denominator. So one of them is going to need b minus 1. There's the big one. And then the other one's going to need, get that out the way. I'm not going to use blue again, but it was so nice when it was blue on one side and green on the other side, because it really gave the visual understanding of what we were doing to rewrite our rational expressions so that they had a common denominator. It's okay, you get it. B times b, and then b times negative 4. In addition, so 2 times b and 2 times negative 1. And of course, the denominator now is binomial 1 and binomial 2. And you can write them in any order that you want. That does not matter. Like terms in the middle. And again, checking to see if I can factor anything towards the end. But I believe, again, b squared minus 2b minus 2. The only way to get a negative 2 multiplied is 1 times negative 2, or negative 1 times 2, and that will not give me my middle term. So get that over the binomial and the other binomial, and I believe we have a final answer. All right, guys. So again, as I was saying, guys, we're definitely going to get to the bottom of the handout. We're going to try to do as much as we can. If there's something that is still confusing, you still have that point of confusion, definitely send me a comment. We can always redo some of these lessons, right, with a little bit more detail. However, 19, where has a GCF? So I remember having a student tell me, where's your steps? And I was like, well, okay. Some kids need steps. So step 1, look for a GCF, always. Your brain should know that your greatest common factor should always be factored out first. So for number 19, that binomial 3x plus 15, 3 can come from the first term and the 3 can come from the second term. So I have 3 parentheses x plus 5. That's what I want to do. And the denominator, x squared minus 25 dots, a difference of 2 squares. Excellent video, excellent handout. Hopefully you caught that one. Now they do not have the same denominator because one of them has 2 binomials. The other one only has 1, but that's all right because I can make it match the one that has 2. The first fraction had x plus 5 and x minus 5. The second one only had x plus 5. So we're adding, by multiplying, the x minus 5 in the denominator. And multiply out now. So we should have just left that how it was, but it's okay. And when I say left that how it was, you see how I distributed the 3 and now it says 3x plus 15 again? You can do that. Because now you got like terms. X times x give me x squared, x times the negative 5 give me negative 5x. So that negative 5x and that 3x can be combined to give you what you need. X squared minus 2x plus 15, all divided by the x plus 5 and x minus 5. And then of course I go, well, can I factor that? Well, technically, no. We are going to get some factoring in, and when I say factoring, the trinomial down to a binomial so that you can simplify. But again, the only way to multiply to get 15 is 1 times 15 and 3 times 5, and it was positive. But here we go, I told you it was coming back. 14, 16, 18, 20, you can already tell that we're starting at 20 because let's take care of the hard, and hopefully, as we work back up, you'll get that understanding. So there's that trinomial I told you about. X minus 3 divided by x squared minus 4x plus 4, all plus x plus 2 divided by x minus 2. So my brain is thinking, well, the second fraction has a binomial. So the first fraction, let's factor that one. So negative, positive. So that means I need a negative, negative. Negative 2 times negative 2 is positive 4. When you add negative 2 and negative 2, you get negative 4. So we factored that correctly. But now I'm looking at it going, that first one has 2 binomials, so my second one needs 2 binomials because they have to be the same, common denominators. Easy enough though, we're going to use the big one, x minus 2 over x minus 2, and now got it. First numerator, x minus 3. Second numerator, though, x plus 2 times x minus 2, which basically is the difference of 2 squares. You multiply it out. But we have the same denominator. That's what we were attempting to get, and we got it. So top, x minus 3 plus x squared minus 4. The middle term cancels out because of the plus minus. And the denominator is just x minus 2 all squared. Put it in order, that's what I'm saying. Yes, x squared plus 1x minus 7, because what we want to do is have it in descending order, so it looks a little bit more correct. And I believe I did that right. I do make mistakes, and it's going to happen. Is it happening in this video? All right, feeling good, looking good. I think we got it. Making a little bit more room because you can see that well enough, hopefully. It doesn't need to be that big. And I'm getting you small and out the way. Otherwise, just don't delete it. I'll delete you right about. Here we go, guys. 18. I like it. The first denominator, k minus 5. The second denominator, k plus 5. So I'm thinking, oh, just multiply by each other. K divided by k minus 5, all plus the k minus 1 over k plus 5. So here we go. The first one is going to need k plus 5 in the numerator and k plus 5 in the denominator. So this time I didn't show the big 1 in blue on the left or the big 1 in green on the right, but hopefully you've seen it enough times you know where that came from, right? The k minus 5 in the second fraction needs to be multiplied by k minus 5. And the k plus 5 in the denominator needs to be multiplied by k minus 5. Because what I do to the top, I have to do to the bottom. And that's what we did. So k times k times 5, plus, because they have the same denominator now, I can write them all in the top. K squared, because k times k, negative 5k, negative 1k, and then positive 5. And that was FOIL. First, outside, inside, last. I could have used the box, but again, that's a whole nother video, right? Denominator, k plus 5, k minus 5. And now what are the terms in that numerator that I can collect to make this look a little better? Oh, opposites, 5k and negative 5k. K squared and k squared, so that's 2k squared. And then of course, negative 1k and the positive 5. And again, guys, if I could simplify that numerator to get a binomial, maybe I can simplify further. But right now, guys, I see the dots at the bottom, k squared minus 25, and I'm happy with what I've got there for number 19. I'm sorry, number 18. All right, so 16 and 14, I think we got time for a little bit more. Again, guys, we don't want the videos to get too long because, as you know, you can only have so much fun with algebra, right? And algebra 2. Shout out to Mr. Rossetti and Know the Man. So, number 16, d minus 1, all divided by d minus 2. And then I recognize, oh, subtraction, don't forget to distribute the negative. I got 3 divided by d plus 5. So the denominators are going to be d minus 2 times d plus 5. But I need to correctly put the numerator in there. So fix that, there we go. The numerator for the first fraction, d minus 5, I'm sorry, d minus 1. I don't know why I always thought all right. But, so for the second fraction, I'm going to need d minus 2 over d minus 2. 3 times d and 3 times negative 2. But on the other side, my first one, hey, here's the green and blue again. Somebody cares about you. We're going to need d plus 5. So d plus 5 in the top, d plus 5 in the bottom. And again, guys, here comes FOIL, or I can do the box. So remember the box. D plus 5 and d minus 1 goes on the side and the top. And then just d times d, 5 times d, negative 1 times d, and then of course negative 1 times 5. And of course, like we've seen so many times, especially if you've been in my videos, we're going to collect the diagonal, the middle terms, right? 5d and negative 1d. Ooh, squeezing it in there. So a nice long numerator now. And again, stop, rewind, watch that again. If it doesn't look like it makes sense, watch it a second time, right? Like terms, d squared plus 8d. Ooh, what about the minus 1d? You gonna put it? You gonna put it? Thank you. So, 7d, a little bit better now. And then negative 6 and negative 5. What? Whoa. Gotta go jinxing myself. All that mess I was talking about, no mistake in this video yet, huh? Wait! It's negative. So I said that earlier, guys, be careful, remembering to distribute the negative. It's actually going to be well, saves me the trouble of explaining that mistake, huh? Now, of course, I'm going to explain it. So, as you can see, guys, two things happen here. Minus 5 after the 1d, the negative 1d, right? That's a like term to the minus 6, so already it should be minus 11. But also, what about the negative that was in between those two fractions? So everything that I did with that 3 should be the opposite. Or you can keep it as the binomial and then distribute the negative, but you gotta understand that it's the opposite of whatever that fraction is. And we're gonna do it to the numerator. But, great video. Like I said, guys, we're gonna have a good one when we started. We had a good 25, 30 minutes, I believe. Look forward to the next one because rational expressions are always going to be something that you enjoy or that challenges you, or maybe that's what it is. You enjoy it because it challenges you. Can't wait to see you guys in the next video. Have a good one.